We started here in CNSI. First results were coming out in 2020, 2021, and they were really astounding. We could pyrolyze methane with artificial sunlight here in the lab, and we knew that we would make hydrogen, but what we didn't know is that the carbon, the solid carbon that came out, would be graphite. It led to a lot of really interesting publications that in turn led to interest and attention. And we now are running 3 desert demonstration projects, and we're building those out to really go on sun in 2025. Mitchell brings a set of skills, and his group and his students bring a set of skills that I never have had and had never developed at all. And that is to really understand the thermochemistry of the reaction part. Right? I focus more on the solid state synthesis part, and Yves as a sounding board for chemistry ideas, basic chemistry ideas, has been fantastic.
So we use concentrated solar energy to break apart methane into both hydrogen and carbon, and that methane can either be natural gas or biogas. But the brunt of the reaction is we're increasing the temperature and energy at this zone enough to break apart those methane bonds. And so the H comes off, combines with itself into H2, which we can pump out later on. And the carbon just comes off and attaches to those carbon fibers cylindrically and graphitically.
Yeah, I think we've gained some new understanding about different chemical physics that are involved. There's some obvious thermal chemistry that's happening, but also some element of photochemistry that we still have a hypothesis, but growing evidence that there's some contribution there that has to do with how the sunlight's actually helping drive the reaction, not just the high temperatures. The U.S. government has identified 4 critical raw materials for both supply chain security and sort of energy security in the United States, and graphite is one of those. So it continues to be a critical raw material, almost like the new oil or gas in a sense, for energy security in the US, but also in other countries around the world. It didn't take long for us to realize the commercial potential of the technology that we were working on, and big step that you make is to go kind of beyond the laboratory into some kind of field system. So we've been able to leverage the Elman funding to acquire new and secure new funding to do a pilot demonstration, which we plan to do out in the desert, Mojave or other parts of American Southwest.
There's no domestic supply today. It's all shipped in from other countries. And the average amount of CO2 emissions to make 1 kilogram of graphite is 10 kilograms of CO2. So you're emitting 10 kilograms of carbon dioxide to make 1 kilogram of graphite, whereas our process, we don't have any oxygen, so there's no O in CO2 to make, so we don't have any emissions. We're just using the sunlight directly. Not only is that more efficient energetically, but it also doesn't stress the grid. It's like a match made in heaven.